Erwin Schrödinger came up with a thought experiment called Schrödinger's cat. And the whole point of the experiment was to try and get across the point that the whole of quantum mechanics is incredibly ridiculous and couldn't possibly be true. It's got to be a mathematical error. And so basically the setup of the experiment is that you have a cat in a box and an atom which has half a chance of emitting something. And so if you've got that, the half a chance of the atom emitting, quantum mechanics says that because it's an atom and it's on the quantum mechanical scale, so it's a scale of the very small, it is both emitting and not emitting at the same time until it's measured. And so you then have a Geiger counter to measure when it's emitting. And this Geiger counter is linked up to some poison, so that when the radioactive element emits, if it emits, then the Geiger counter will get some poison released, and the cat will die. And so you leave the experiment on for the time that it is that gives the element exactly half a chance of emitting. And so it's both emitting and not emitting. And so in theory, the Geiger counter is picking up and both picking up and not picking up the radiation, and so the poison is being both released and not released. And so the cat is both dead and alive. But what seems to happen is that as soon as you open, what would happen is that as soon as you open the box, the cat, what you'd see is the cat either dead or alive, and it's because the atom was in what's called a superposition of both emitting and not emitting. And so if you run it through the system, the cat is both in a superposition whilst you're not looking at it, whether it's dead and alive. And what seems to happen, what in theory would happen, is that when you look at the cat, you collapse its wave function and the superposition, and it is both dead and alive. But I think what would happen, because of course this doesn't happen, but it's about working out when the superposition stops, or whether it stops at all, because of course you could run through and then say that you are both in a superposition of seeing the cat dead and seeing the cat alive, so you're doing both at the same time. What would this feel like? Well, it would feel like you're seeing it dead, and it would feel the same as if you were seeing it alive, because you are basically two people then. And there is an interpretation of this called the many worlds interpretation, where basically what the many worlds interpretation says is that as soon as you observe the cat, the whole universe splits into two different universes, one where the cat is dead and you look at it dead, and another where it's alive. But what would happen in real life is that because the observation, which is the Geiger counter, and in quantum mechanics, an observation seems to be if it's measured and the measurer can do something about it. So with a Geiger counter, if it's linked up to a Geiger counter, the Geiger counter would it can be linked up, was normally linked up to a scale, and it'll a counter, and so the Geiger counter is doing something about the emission, and so it would probably be the fact that the superposition would be collapsed at the Geiger counter, or not collapsed at all. So it's all very strange, but it is left over to interpretation, which is whether the superposition collapses at the Geiger counter or whether it doesn't collapse at all. And so, in theory, if you're in the lab alone in this doing this experiment, and you probably would be in the lab alone if you were doing this experiment, because nobody else would want to be killing a cat or have a half chance of killing a cat. So you'd be in this lab alone, and then if someone was to walk in, they'd collapse your superposition of being in, and so they would be in a superposition of both seeing you, seeing the cat, both dead and alive. But this gets quite complicated, and I think the easiest way of thinking about it is that the Geiger counter itself acts as an observer and stops the superposition getting any further.